A graphic of the current orbital position of the Spitzer Space Telescope. Astronomers observed a microlensing event from 3 different locations in space: Spitzer, the Earth, and the Kepler K2 satellite, and used them to measure for the first time, in principle without ambiguity, the mass and location of a microlensing body 77 Jupiter masses in size. Credit NASA's Spitzer Space Telescope. The path of a light beam will be bent by the presence of mass, an effect explained by general relativity, and a massive body can therefore act like a lens, a so-called gravitational lens, to distort the image of an object seen behind it. Scientists first confirmed this prediction quantitatively during the now famous total eclipse of the 29th of May 1919 by observing starlight bent by the mass of the Sun. Microlensing is the name given to a related phenomenon, a short flash of light produced when a cosmic body, acting as a gravitational lens, changes the intensity of visible light from a more distant, background star as the body's motion fortuitously moves in front of it. About 30 years ago, scientists predicted that if it ever became possible to observe a microlensing flash from 2 well-separated vantage points, a parallax measurement would pin down the distance of the dark object. The Spitzer Space Telescope is currently orbiting the Sun at the distance of the Earth, but trailing the Earth at a location about only quarter of the way around in its orbital path. Years ago, CFA astronomer Jennifer Yee led a team to make the first parallax microlensing measurement of a small stellar object using both Spitzer and ground-based telescopes. One complication was that measurements made with only 2 vantage points leaves a possible ambiguity in the result, but a 3-point measurement would eliminate that uncertainty. In a new paper, Yee and a large team of her colleagues report the first microlensing event seen from 3 well-separated points: Spitzer, the Earth, and the Kepler K2 mission, which has an orbit similar to that of Spitzer but which currently trails the Earth about 1/6 of the way around in its orbital path. The lensing object, known as MOA2016BLG290, was determined from these measurements to be an extremely low mass star of about 0.07 solar masses, 77 Jupiter masses, and situated about 22,000 light-years away in our galaxy. The result, besides detecting an object intermediate in mass between a star and a planet, demonstrates the power of microlensing parallax measurements predicted decades ago. Explore further distance measurement of a microlensing event. More information. Wei Zhou et al. An isolated microlens observed from K2, Spitzer, and Earth. The Astrophysical Journal 2017. DOI 10.384720418213AA93 FA.